Big hello to everybody. Just wanted to do a quick video on potential difference. The egg is currently running on what is called potential difference and has some very good advantages over running a pulse type motor normally or anything else for that. In fact, I've got here just to show you how it works. Two caps. This one here at the moment it's got near 15 volts. This cap does leak down a little bit, it's not very healthy. The other cap here has 6 volts in it. The way I've got it hooked up, I've got the negative of the 15 volt cap going into the negative of the 6 volt cap. Now these are 60 volt caps, or 63 volts, so 6 volts it's only partly full, you could say, which means that the positive terminal has more electrons in it on that cap than the positive terminal on the cap with the higher voltage in it. So that's what they call potential difference. So yeah, we've gone from negative to negative, from positive through the globe, and we're going to go back into positive. So what you'll need for this is a bit of paper and a pen, just so you can write some figures down for yourself. I will calculate them as we're going through. So what we'll do now is we'll add up the two caps, which is 15 volts plus our 6 volts, which of course gives us a total of 21 volts all up. So what we'll do now is we'll hook our light up. Now the light's a 24 volt neon light, so like I said, it's coming from positive to positive and the two negatives are hooked up. So we'll give that a run now for a little while. Sorry about the brightness. And then we'll have a look at our voltages again. So if you add them voltages up, 13.36 plus our 7.67, and we get a total of 21.03, and we started with 21. So we'll hook it up again, give it another go. Give it a long run this time. Okay, so now we've got 8.41 volts in one cap and 12.63 volts in another, which gives us a total of 21.04. So the more we do this, the higher our combined voltage ends up. Now the strange thing about this is eventually the voltage bleeding out of one cap will start to slow right down. The voltage going into the other cap will start to slow right down. And as you can see, it's starting to slow right down now. And there comes a balance between the two, and that balance is what this is actually running on at the moment. So just about stopped there, and look, neon's still going. That is the balance of power we're looking for that is running this at the moment. So what I'll do now is it's going to take my leads off of here to my meter and put them on the 6 volt battery I've got over here. This is extremely hard one-handed. Okay, This has been running for about 7 hours now, as you see it. Now the battery voltage on the 12 volt battery was 12.27 when we started, and the 6 volt battery was 5.94 volts when we started. These have been sitting for about 4 days now, so the voltage had stabilised in them very well. So 12.27 on the 12 volt, 5.94 on the 6 volt. This is hooked up the same as the caps. We go from negative on the 12 volt battery through to the negative on the 6 volt battery. The 6 volt battery becomes positive, becomes our negative, which you can see by the yellow lead goes to the negative side of the power to the pulse motor. Positive lead goes through the red one and into the positive side of our pulse motor. The high voltage line is coming off of there and going back into the 12 volt battery. So as this is running, it's actually charging the 12 volt battery. After 7 hours, it hasn't come up a lot, but it's come up to 12.29 volts. And our 6 volt battery that started at 5.94 is pretty much the same, 5.95, 5.96. So both batteries have come up in voltage, and it has been running this motor for, like I said, about 7 hours now. So that's what they mean when they say running things off what they call potential difference. So I just thought I'd share that with you. It's a very interesting way of hooking things up, and it's running a motor for 7 hours, and the voltage in the batteries, if anything, has gone slightly up. So there you go, that's potential difference energy.